In these last examples, we'll start with an equation that is in standard form, and what we'll do is write it in vertex form so that we can find all the coordinates and the zeros, all that stuff. Okay, so first, we have an equation that's in the form y equals ax squared plus bx plus c, and we want to convert it into the form y equals a times x minus h squared plus k. That is our, that's where we're going with this. So first notice a is 1, so there's nothing to factor out. I don't have to pull out the a, okay? So I don't need to do that step. But here's what I will do. I've got x squared plus 6x. I'm going to group those two terms together, leave some space for a third term, and then put plus 5 outside of the parentheses. My goal here is to turn this, I'm going to add a special number to the inside here that will turn the stuff in the parentheses into a perfect square. We kind of went over this when we talked about completing the square, which is how we develop the quadratic formula. The story is whatever you add to, it's basically adding a number to the right side of this equation here. You can't just add in any number. You're going to have to also subtract it. So it's like if I did plus 2 minus 2 plus 7 minus 7, you're not actually changing the equation. We're just like manipulating it. So the number that we add in here, remember that x equals negative b over 2a, so it's related to that. So it'll be half of the middle term, so you're going to take 6 and divide it by 2, and then you're going to square it. So 6 divided by 2 is 3, square it, we get 9. So if we add 9, I'm going to have to also subtract 9. The reason I wanted to add in 9 is because that turns this stuff in the parentheses into a perfect square that you can factor. This is going to factor like, well, what two numbers multiply to 9 and add to 6? Well, 3 and 3. So this becomes x plus 3 times x plus 3, or x plus 3 quantity squared. So that turns this whole expression in the parentheses into a perfect square. And then on the outside here, we got plus 5 minus 9, which is minus 4. So this tells us a is still 1, but now h is the opposite of this number, so it's negative 3. And k is now negative 4. So now I know that my graph is going to open up. My vertex, oh, and it opens up because this coefficient 1 is positive. The vertex is the opposite of this number, so negative 3, negative 4. So negative 1, 2, 3, 1, 2, 3. So there's my vertex. It's going to open up, so I will find two x-intercepts. Let's go ahead and solve for them. We find the x-intercepts by setting the equation, and I'm going to use this version of the equation, x plus 3 squared minus 4. Set it equal to 0. Then we can use the square root method. Add 4 to both sides. We get x plus 3 squared equals 4. Square root both sides. We get x plus 3 equals plus or minus the square root of 4, which is 2. This gives me two equations. X plus 3 equals 2. X plus 3 equals negative 2. Subtract 3 from both sides, we get x is negative 1. Subtract 3 from both sides, we get x is negative 5. So my two x-intercepts are negative 1, 0 and negative 5, 0. I'm going to go ahead and plot all of these things. So there's my vertex. Negative 1, 0, negative 1, 2, 3, 4, 5, 0. Great. We can also find the y-intercept. If we look at the original version, it's a little bit easier to find what the y-intercept is, because if you plug in 0, this goes away, you're just left with 5. So the y-intercept is going to be 0, 5. Let's go ahead and plot that. 1, 2, 3, 4. There's 0, 5. And in fact, if you like, if we want to be really precise, start at the middle. That y-intercept is 3 units to the right. You can go with 1, 2, 3 units to the left. There we go. Okay, now I can go ahead and graph my parabola by connecting the points that I plotted by a nice smooth curve. All right, things to notice. What did I do in order to put this equation in vertex form? If I had a coefficient other than 1, I would pull that out first, and then group the first two terms together, leave space for a third term that we're going to add in, and then put the constant term outside of the parentheses and leave space to subtract that term that you added in. What term are we going to add in? Half of the middle term squared. So add it in here, subtract it off there. That converts this into a perfect square, so we'll have to factor that parentheses. And then simplify these two numbers, getting -4, and there it is. It just kind of falls out. Let's do the same method for one more example. Example number 9. So y equals -2x squared plus 4x minus 8. All right, things we need to be aware of. Here, a is -2. We're going to have to factor that out of the first two items first. So I got -2x squared plus 4x. These guys I'm going to group together, and then the -8, I'll leave that on the outside. So I will first factor out -2 from the first two terms. So I've got -2. This becomes x squared minus 2x. Leave some space, and then I have -8, and I'll need to leave some space. Remember, we're leaving some space so that we can add in a number here. What number am I adding in? It'll be the middle term divided by 2 and then squared. So -2 divided by 2 is -1. Square it, we get a +1. Okay, now I'm not going to subtract off 1 here. Instead, what I'm going to do is notice that I didn't just add 1 into my equation. Sorry, excuse me. This was y equals -2x plus 4x minus 8. So we get y equals this. I added a 1 to the inside of the parentheses, which is just like, because there's a factor of 2 on the outside, I actually added in a -2. -2 times 1. I added a -2 to the right side of this equation. So because I added in a -2, I'll have to put in a +2 to compensate. So just verify with yourself. If you were to expand this all out, -2x squared plus 4x, then you would have a -2. So I'm going to have a +2 in order to balance this equation out. Great. So what we have now, -2 on the outside. This factors as x minus 1 squared. And then -8 plus 2 is -6. So there it is in vertex form. Leading coefficient, a is -2. H is the opposite of this number, so it's a +1. And k is -6. So let's write down our key features. First of all, the leading coefficient is negative, so this will open down. Our vertex will be 1, -6. Let's go ahead and plot that. So 1, 1, 2, 3, 4, 5, 6. And it's going to open down, so I should expect to see no X-intercepts. Instead, I can plot some other points. Maybe my y-intercept. Oh, let's go ahead. My y-intercept will have x-coordinate 0. And if I go back to the original equation, if you plug 0 in here, this is 0, This is 0. We're left with -8. Let's go ahead and plot that point. 1, 2, 3, 4, 5, 6, 7, 8. All right, and if we use the symmetry of the graph, here's my vertex. Look at the vertical line through the vertex. This point is 1 unit to the left of center, so I can plot this other point, which is 1 unit to the right. X coordinate is 2, Y coordinate is again -8. So pretty easily, with very few calculations, I can draw the graph. Again, just reviewing what we did. The equation, I saw I had a leading coefficient, so the first thing that I did was I pulled that out. I factored out the leading coefficient. I added into the parentheses, half of the middle term squared. And then I had to compensate or balance by adding the opposite of what I added in. So I added in a -2. Got to also add in a +2 so that I didn't actually change the equation. After doing that step, factor it. This will always become a perfect square. You did that by design. Simplify this, these last two numbers. And now it's in vertex form, and you can graph it pretty quickly.